Hi everyone. I'm going to change it up today. I'm going to do a non-bridge related story. Been a lot of bridge news here lately, but this was a story that was sent to me by a channel member, Dr. Evil 814, which I really appreciate. This is from my area where I've grew up. This event occurred about 40 minutes north of Kansas City in Platte County. And in mid-March 2024, it was reported that a small earthquake hits the Kansas City area, which is not a common occurrence. It was reported to be a magnitude 3.5 event. So to give you some idea, 3.5 is in between minor and light. So it's a small earthquake. Now let's run this segment from the news story.
Fox 4 has uncovered some new information about that reported earthquake in Platte County a few weeks ago. Turns out it wasn't an earthquake. The trembling was caused by a mine collapsing.
So the type of mine they're talking about is a limestone mine. One of the major targets for limestone mining in this area of Missouri is what's referred to as the Bethany Falls limestone. It's a really thick bedded or massively bedded limestone. The thickness varies from 15 to 30 feet. And you could see here the typical mining method is, if the Bethany Falls is close enough to the surface, they'll just do an open pit mine. But more often than not, the mine's going to be located 150, 200 feet or more below the ground surface. So they use mining methods, and this is called room and pillar mining. So they excavate the seam of rock and leaving pillars to support the roof rock as they go. And rule of thumb for the Bethany is that they'll have what's called an extraction ratio of around 50%, which means they'll take out 50% of the rock and then leave 50% for support. And then over time, they'll go back and what they call rob the pillars, and they'll excavate more material and they'll increase their extraction ratio. Now, let's go back to this news story real quick.
Fox 4 News first learned more about this incident from an anonymous email saying it was actually a mine collapse at the Stamper Mine in Farrellview, Missouri that caused the ground to rumble on March 15th and not an earthquake. A geophysicist with the United States Geological Survey tells us that's correct. And further investigation into the March 15th incident shows a depth of 0 rather than the 6 miles that was originally reported. So this happened close to ground level, according to the USGS.
So what could cause a limestone mine that's using room and pillar methods to collapse? Well, if you lose support from one or more pillars, you could have a collapse. Sometimes you have shale that is exposed in the roof of the mine. So let's say the Bethany Falls is 20 feet thick in this given mine. They'll leave limestone at the bottom and top to act as a floor and roof, usually 4 feet thick, to provide stability to the mine. Sometimes the limestone can thin out so they don't have as much roof cover in limestone as they thought. And so you can have falling of rock from the roof line into the floor of the mine. And in more severe cases, enough material falls in and the collapse propagates to the ground surface and forms a giant sinkhole. So we can see some issues here. We've got joining patterns. We've got fracturing. A lot of times these pillars have a narrowing at the midpoint, and that's usually because the stresses are highest there and rock pops off over time or spalls off, reducing the diameter of the pillar. And as the diameter reduces, the stress from all the overlying rock increases at that pillar location. Is a photo of a rather isolated roof fall in a room and pillar mine. Here's an aerial shot of a mine. You can see the red outline of the ground subsidence that resulted from a collapse of the mine opening down below. And that could be 150, 200 feet below ground where that mine collapsed. So again, some terminology here. We've got the roof, we've got the pillars. This is the floor of the mine. Now let's talk about some engineering properties of limestone. Typically you have unconfined compressive strengths of around 12,000 pounds per square inch in the Bethany Falls. Other limestone formations can have nearly triple that strength. So an unconfined compression test, it gives you an idea how strong the rock is, where you take a sample, usually from a core, and you put it in a hydraulic press and you load the specimen until it fractures. And if you take the load that was applied by the cross-sectional area of the sample, you come up with the unconfined compressive strength. Also, this is tabulating typical pillar heights. Could be up to 36 feet on average, minimum around 16 feet, maximum 124. I'd be curious where that is. So this gives you an idea of the roof spans. Most frequent roof span is 40 to 45 feet. There's just a picture of a stable mine opening. And again, there's a schematic of the room and pillar. The square are the pillars. The space around it is the open space in the mine where the limestone was extracted. Now, often installation of rock bolts are needed to support the roof. That's because of jointing, if there's weak rock in certain sections of the roof. And I found this video online. I'll put a link in the description. I think it's quite good. It shows you some of the measures they take.
Looking back, what we should have done was sound tested the roof. We would have known that that rock above us was loose.
The way to check a roof for integrity with by sound is to take the bar and tap it against the roof, and you can also put your hand against the roof to feel the vibration, and you can tell by the sound and the vibration if it's solid or if it's loose.
Now, it's interesting to me how sometimes relatively low-tech measures can yield very useful engineering information. All right, you can see the anchor bolts here. So what he's doing is he's pounding the roof rock with a metal bar, and if it has a high-pitched ring to it, that means it's solid rock. But if there's a dull thud, that means there's a joint or maybe a big piece of rock about to fall off or fall down from the roof. And in that case, you would install anchor bolts. So you drill a hole and you have these expanding wedges that expand against the hole as you tighten the lock nut on the surface plate, and it provides strength and support to the roof rock. And oftentimes these are extending roughly 4 to 6 feet past the roof line, and they may be spaced every 4 feet in a given area that's being stabilized in this fashion. It's kind of interesting. I test concrete drill shaft foundations for bridges, and occasionally, because of various issues that aren't related to what we do, but if the access is such that sometimes we can't assess the quality of the concrete in the last few inches, and in those situations, we recommend that the drill shaft be sounded with a small hammer. I recently went to a project where the condition of the shafts were in question, so there was no mechanism to do the typical non-destructive testing that I routinely perform in my company. And I actually had to fly to this location. It was a sudden trip, and I asked my client to provide certain things so I could just have a carry-on, and that was various sized hammers. I knew I wouldn't be able to bring a hammer on as a carry-on on an aircraft. And I get there and I'm just tapping the top of the concrete, looking for areas that may be cracked or about to separate from the concrete. So another thing they do in the mines is to remove loose rock. So you want to make sure you've got nice stable rock and all the exposed surfaces in the mine.
It's a temptation, no matter if you're on a mechanical scaler or a hand scaler. You really want to go out there and get that big rock, and you have to refrain from doing that and work safely out to it.
So what he's talking about there is you see a giant loose rock, and the temptation is to go for the big rock instead of the smaller rocks around it and work your way to the big rock, because you might find you dislodge the big rock and you've destabilized a big section of the mine. So the other thing they look for in mines is if there's been recent roof falls onto the floor of the mine. So this mining activity has been going on for a long time, well over 100 years in this area of Missouri, and similar methods are used in this type of rock throughout the eastern United States, from the Midwest through the eastern part of the U.S. And these methods are used in similar limestone mines from the Midwest to the northeastern U.S. You've probably heard of the Kansas City Chiefs. Their founder was a businessman named Lamar Hunt, and one of his business ventures was he converted limestone mines into offices and storage in the Kansas City area. And one of his complexes is called Subtropolis, and it's 55 million square feet of space. It's in the giant bluff in the Kansas City area, And to the north of this subtropolis property, he developed an amusement park, Worlds of Fun. So he was involved in a variety of activities. And his mine is also in the Bethany Falls limestone. It's 160 feet underground, and it consists of a grid of pillars and rooms. And the pillars are 16 foot tall, and the opening between pillars is 40 feet wide, and the pillars are 25 foot square. One of the benefits of this facility is that the temperature remains between 65 and 70 degrees naturally all year long. I think I read years ago that George Lucas stored his master copies of the initial Star Wars movies in this facility. Let's take a look at what it's like to drive through Subtropolis. I mean, it's basically like its own city, and you can drive vehicles in there. There's office space. There's people with scientific instruments where they're doing things that can't be subject to ambient vibrations that you would have in a normal building near a roadway. So it's very much like a city street system layout in a grid pattern. The U.S. National Archives. So let's look at what an outcrop of Bethany Falls limestone looks like. It's massively bedded, and it's a much sought after rock formation in terms of mining it and crushing it for use as concrete aggregate, gravel roads, as well as cement production. So I want to touch on, how did this limestone form? This limestone, the Bethany Falls and others like it, formed about 300 million years ago in a huge inland ocean that was part of the supercontinent Pangaea. So you can see this was what was to later become North America. You can see the blue, this huge inland ocean, marine ocean that extended from the Midwest to the east coast of the United States, or what would be the east coast. This inland ocean was typically about 100 feet deep. So to me, I just wanted to get into this story. It was fascinating. Apparently the people who operate the mine have said nothing publicly, and apparently they're talking to mine safety officials, but it makes me wonder what could have caused this collapse. Was it a failure of rock bolting? Was it a failure of maintenance? You know, sometimes these, or quite often these limestone complexes, once they've moved on from an area, they're allowed to fill with water. So there's no ongoing maintenance or inspection once a portion of the mines become water filled. And you can have mines that were developed, nearly 100 years ago that are in areas that are newly developed, and people have no idea that there's a mine underneath their location. And several years ago, I worked on a mine remediation project when DOT was putting in new bridges over an area that had been undermined. And the project was to fill the mine opening with flowable fill. So cement, fly ash, and water slurry mix, so that it just prevented the mine from collapsing in the future, which could easily form a sinkhole that would swallow up a bridge and a roadway. So nothing that you want to have underneath your bridge project. So I hope you enjoyed this different type of video from me today. I want to send a shout out to the channel members. I really appreciate your support. It's been really gratifying seeing the growth of the channel. I also want to send a shout out to those of you who have provided super thanks. That's another way to support the channel. Also, I want to thank those of you who have liked, subscribed, and commented on these videos. And still, I've got that digital download of the biggest civil engineering disasters from the past 100 years. There's a link in the description. Thanks very much, everyone.